Okay, so now we're going to look at a slightly more complicated shape, and this is just going to be a shape that has two rectangles stacked on top of each other. So what we're going to have in this problem is we are going to have a rectangle there, and it's going to have this T shape. The dimensions will be 12 by 4 for the first rectangle and 12 by 4 for the second rectangle. We're going to put a Z axis in the middle of it. This is where our centroid is located, and the distance from the top to there is 6, and the distance from the bottom to there, that is 10. So this is the shape that we are going to be dealing with. What we are going to have to do, we're going to have this is shape 1 and this is shape 2. We are going to apply the information from the last section to each one of these two shapes. In other words, we will work this top shape 1 individually, and then we will work shape 2 individually. So the information that we need from shape 1, we need to know the area of shape 1 is going to be 12 times 4, that is 48. The distance from the centroid of shape 1, the absolute value of D for shape 1, right? So the centroid of shape 1 would be 2 in there, right? And so that would be, if the Z is 6 and this is 2 down, so the D for shape 1 is going to be 4. That means that D squared A for shape 1 is going to be 16 times 48. And I'm going to take out my calculator real quick. Just give me 1 second. In the calculator, I am putting 16 times 48. 768. So the D2A for that is 768. Now the second shape, all right, so we're going to hold on to that information. I'm going to shift my board over, and on this side of it we will calculate for shape 2. Now notice shape 2 is also a 4 by 12. So the area for shape 2 is still 48. The distance for shape 2, so shape 2's centroid, right, if it's 12 up and down, it's going to be at 6. The distance from the bottom to the actual centroid is 10, so that difference between those of where the centroid is of shape 2 and the centroid of the piece, that distance is 4. So our D squared A here is also going to be 768. So I'm going to take that information, and now we need to find the moments of inertia for these two. Now the difference here is the moments of inertia for the two different shapes are going to be very different, because the bottom-teed piece is in a joist formation, and the top of the T is in that plank formation. So I'm going to erase some of this so that we have some space to work with, but that's still the shape that you have. So if you are taking notes, you'll be fine. If you're not, you might want to pause the video here, write down the information that you see, because this information is not going to be on screen when I go into my next part. All right, so okay, so for now we're just talking about shape 1, which was the top of the T. All right, so remember we still have this T shape. Shape 1, that's the top of the T. There's shape 2. Now, with the top of the T, remember that this is my base because the axis I'm talking about is that horizontal axis. So I'm going to apply that IC equals base times height cubed over 12 formula. And so in this case, my base is 12 times 4 cubed over 12. And so my I sub C value is just going to be 64. The IZ, right, which is the moment of inertia with respect to the centroid and the axis that we're given. So remember the I sub Z formula here. That's going to be IC plus D squared A. So in this case, that will be 64 plus, now referring back to the information that you should have written down, that's going to be 4 squared times A, which is 48. So my IZ value is going to be 64 plus 4 squared times 48, 832. So my IZ1 is 832. So I'm going to save that value off to the side. IZ1 is 832. Now I'm going to do the same calculation for the 2, right? So I'm going to do the same calculation now for the second part. So I'm going to erase my work here and here, and just plug in. Now this time, because I'm looking at shape 2, my base is 4, and my height in this case is 12 cubed divided by 12. So as we can see, the I sub C for this part, so that's going to be 4 times 12 to the third divided by 12. My IC in this case is going to be 576. That is a much larger value than what we had in the first one. So down here, my IC is 576 plus D squared. My distance is still 4 squared. The area is still going to be 48. So I take 576 plus 4 squared times 48, and that gives me 1,344. That is the moment of inertia for the second piece with respect to the z-axis. So, quite simply, the overall moment of inertia is just the sum of those two values. So I've got the 1,344 plus 832. That gives me 2,176 as my overall moment of inertia for that compound piece. Using those two videos, you should be able to get through the problems more easily. If you have any questions, please make sure you ask them in class. Good luck with your work, and I will see you when I see you.